have 2 events every month, a presentation night like this one, which we do most months, and a project night, which happens on a different week during the month, where we are in the same space usually, but at large round tables, 10 people to a table, clumped together by interest. You should definitely come to one of those. You don't need to have a project to work on. All skill levels are welcome. You can just find someone who is interesting for you to talk to and get something done in 2 or 2.5 hours. The next one of those is on March 8th, and that's the dates going around on the calendar. Starting in April and into May, we are going to have, for presentation nights, we are going to have a special series of rehearsals for the people from Boston who are speaking at PyCon. And this year there are 11 talks from Boston that are going to be at PyCon US in Portland in the beginning of June, which I'm very pleased by. If you look at the distribution by cities, of course, San Francisco has blown us out of the water. They have something like 33 talks. But after that, the next largest city is Boston. So I'm pleased by that. And I'm very proud of all the people who have put effort into their talks. And a couple of them are here in the audience, and they're looking pleased with themselves, too, which they should be doing. So we're currently trying to schedule those. The difficulty there is that everyone wants to do their rehearsal the day before they're supposed to do the talk, and that doesn't work out logistically. So we have to find dates and get people to do their rehearsals, and et cetera, et cetera. When we are not meeting, we have a couple of offline ways to stay connected. One is a mailing list, and one is Slack. This URL will get you to an app where you can invite yourself into the Slack team that the Python community has running, and we have a Boston, Mass. A channel inside that Slack team, if you're interested in chatting between meetings with other like-minded Boston area Pythonists. So tonight we have 2 talks. The pizza has been sponsored by Klaviyo, and Andrew got away from me. There's Andrew. Andrew is going to tell us about Klaviyo.
Cool, thanks. Hey everybody, my name's Andrew. I'm the technical co-founder and CEO of Klaviyo. We use a lot of this stuff. We use a lot of Python. So I'm sure, how many people have heard of Klaviyo? Has anybody heard of Klaviyo? All right, here we go. We got a couple of people. I'm betting most of you have not heard of us. We're a startup. We're over by South Station. We started in 2012. We're focused on email and marketing software. You can think of us as a much, much better constant contact, or really I wouldn't put contact in there. Maybe a better like MailChimp. But anyways, we've been pretty heads down, so we're a bootstrap company. We're now about 30 people. We've got over 1,000 customers, and it's all built on Python. Anyways, yeah, we're starting to pull our head out of the sand a little bit. A little bit about our stack. Python was not the first language I ever used. How many of you have used Cold Fusion? Anybody? Yeah, sorry. That really sucked. I did that for a few years. How many of you have had to deal with IE6? Yeah, I had to deal with that too. That sucks. Anyways, Python's much nicer than that. So we're built on Django. We've used Tornado in the past, but Django's just easier. We do a lot with Celery. We do a lot of our deployment with Fabric. So it's kind of Python through and through. We basically use Python until it stops working, and so far that's been few and far between. So anyways, Ned, thanks for having us. You'll see this slide a bunch. Yeah, we decided that to sort of announce that we're here. We're going to be sponsoring the next couple of these meetups. So if you come to these regularly, I guess you'll hear this on repeat. But anyways, yeah, if anybody's interested in kind of startups and doing Python, would love to talk to you. So thanks.
Yep, thank you. When we are done here in about 2 hours, a little less than 2 hours, we're going to be going to Mead Hall, and Twilio is going to be sponsoring drinks there. And I encourage every single one of you to go to Mead Hall and completely overwhelm the place and make Twilio regret saying that they were going to buy another one here. The talks that we're seeing tonight are both talks of a person who said, hey, I built a cool thing and I'd like to tell people about it. And if you have built a cool thing, I definitely encourage you to think about doing a talk here. But I also want you to not think that you have to have built a cool thing in order to do a talk. Lots of people have come up here and done talks about things they didn't build, about things they didn't quite know about things that they were hoping to build, about stuff they had just learned about the other day from the language and so on and so forth. So there's lots of possibilities of talks that can be up here other than, yo, I'm a programmer and I built a cool thing, right? Which is the kind of talks we're going to get tonight. It doesn't have to be that kind of talk, right? There's lots of ideas. And afterwards, at Mead Hall, especially if you think that you do not have something that you can talk about, I want you to come and talk to me. And I will tell you what your talk is going to be. That is my special superpower, is finding the talk inside of people that they didn't know was there. And I swear, this is true. I have said that up here and then gone to the bar and had someone come up to me and say they didn't have a talk, and 10 minutes later we had 3 ideas of give talks. That's not a coincidence, right? We work at it here. We can look into it and find topics for you. So, do it, right? Right, Adam? Right? You're one of my victims, right? Yeah, okay. It works. It works. Okay. So, where's Jay?
Here.
Jay, let's go.
All right.
So, Jay is our first speaker.
Spiller. I'm too eager.
We should have set this up earlier.
I think we need a mic. Ooh, that's weird. Yeah.
Hi, everybody. Hi. My name's Jay. Hi. I wrote a Pytest plugin, and so can you. I don't have a slide like talking about myself or my place of work, so I'll just tell you. I'm Jay Luker. I'm a senior software engineer at the Harvard Division of Continuing Education, TCE for short. We are responsible for the back end of the extension school, delivering online lecture videos to students all around the world. We use an open source platform for video processing and delivery called Matterhorn. It's a Java-based program, but we also use a lot of Python in our internal tools. Some Ruby as well. For the AWS, we write chef recipes. We have an OpsWorks stack. We do a lot of cool stuff. My work generally revolves around things like collecting user analytics data, centralized logging, automated testing stuff, so like DevOps stuff, I guess. I've worked in library information science, worked for a NASA project for a long time where we digitized indexed astronomy literature. But I've been at DCE for a year and a half now, and it's fantastic. I wish I could tell you we were hiring, but maybe we are. But it is a great place to work. Harvard in general is a great place to work. I will say that as well. But, the benefits are great. The diversity is amazing. People are good. Environments are cozy.
You're not able to hear you back.
Is your mic on?
I turned it off because it sounded kind of weird, but yeah, if you
Try
can't
the
hear
mic.
me, let's turn it back on.
How does that sound? Is that better? Okay. Sorry about that. I thought I was projecting. Okay. Thanks. So here's what I hope is going to happen. I'm going to talk about Pytest. I'm going to talk about Pytest plugins, how they work. I'm going to talk about a really cool website testing service called Ghost Inspector. And then I'm going to finish by talking about a Pytest plugin I wrote called Pytest Ghost Inspector that wraps the Ghost Inspector API calls within the context of the Pytest framework. That's what I hope is going to happen. What might happen is I'll be shuffling a lot of windows around and trying to do live demos and stuff. So to start with, I don't want to go into a lot about what Pytest is, but I do feel like I should take this opportunity to evangelize it a bit because it is pretty awesome. It is a open source Python testing framework If you've used unit test, it's somewhat analogous to that, but kind of plus plus. Analogous to nose. Some people use that. How many people use Pytest? A lot of people, yes, that's good. It can also be used as just a framework agnostic test runner. You can write your tests in nose or unit test and run them with Pytest. You can go to the pytest.org website. They have awesome documentation. They have a great GitHub organization where they have the repositories for the Pytest software itself and many of the popular plugins that people have written and contributed back to the organization. And you can install it with pip, of course. So here's where I shill a little bit for Pytest. So the reasons that I think Pytest is so great come down to two main things, and in combination. I think first of all, it's less work and less boilerplate for most of your cases. Like you can very quickly write simple tests to cover a large amount of your needs. You don't have to import stuff. You don't have to write test classes. You don't have to use third-party modules like mock. Although I love mock. I don't want to say anything about mock, but Pytest has that kind of stuff built in. Here's an example of a couple of functions under test, and then a couple of Pytest test functions. And if you were to run that, you would get a success and a failure. So less work and boilerplate for your 80% cases. So what's being shown here is a test foo that passes and a test bar that fails. And you can see that the output from the report there shows you what failed, what comparison it was, what the value should have been, and so forth. So the other part of this thing that I think is so great about Pytest is that it has a lot of stuff built in for the other 20% of your cases. So you can do things like parameterize. They actually call it parameterize. But you can basically decorate your test functions with arguments. And if you decorate your test function like I do here, with a set of 3 different argument inputs, the test will run 3 times, once each for each of your arguments, for each of your input values. So here is just a fake test for a fake login system where we're testing different usernames and passwords. We maybe want to throw in some Unicode characters to see what happens. And then we have, if you can see, we can move mouse over here. So here I've marked one of the arguments to the test function is it's expected to fail, so I can mark that. Like I said, you don't have to bring in third-party modules like mock if you don't want to. You can do things like monkey patch sections of your code. This example here, basically just if you want to make sure that none of your code under test actually issues an HTTP request anywhere, you can just disable requests in that way. I should say that one other thing that's happening here is, sorry, I keep losing my mouse. So I'm here. This sort of illustrates one of the other Pytest features where you can decorate functions with the Fixture Decorator. And what this does is make them available to your test functions automatically. Here, in this case, I've set the fixture to be auto-used. That means it's sort of the equivalent of putting it in a setup teardown method. It'll always be executed at the beginning of each of your tests. So with Pytest, all of your assertions are done with the assert keyword, method, I don't know what that is, built in. that might seem strange if you're used to like working with unit test and you're used to specifying, assert contains or assert is instance of, assert raises, things like that. In Pytest, you don't do that. You use assert for everything. Even with the exception of if you're expecting an exception, you will use the Pytest raises context manager as shown here, and then you can capture that exception info in the scope of your block and assert what the exception actually was. Okay, so hopefully I've sold you on Pytest. Let's talk about plugins. So plugins for Pytest basically comprise most of the code base. The core of Pytest is apparently 300 lines of code plus a bunch of plugins. So it's eating its own dog food, so to speak. They call it a one-to-n hook-based architecture, and that means you have hook functions that offer entry points into the functionality of the test execution. And each of those hook functions, and there's a one-to-n relationship. So for each entry point that Pytest provides for plugins, an n number of plugins can define a hook function to hook into that functionality. They can specify, I want to be the first one run, I want to be the last one run, or I want to wrap all the other ones that get run, and you can kind of argue amongst themselves about who gets run when. There are two types of plugins. When you're thinking about Pytest plugins, there are what's called local plugins, which consist of just a special file called conftest.py, and if you drop that into your test directory where your tests are, Pytest will find it and execute it first. And then there's third-party plugins. I'm going to talk a little bit more about each of those things in a second. And then the hooks, this is kind of an artifact of the documentation, but they're grouped into roughly 5 phases. So there's hooks that let you do things during the initialization, command line parsing, then the actual collection of the tests, the discovery of test files, so forth, the running of the tests, reporting of the status of the tests, and then if you need to do debugging. And so an example of a local plugin, first of all, so I already said, so per directory customization. So you drop a conftest.py file into your test folder, Pytest will find it and execute it. You can put, if you group your tests into directories, you can specify different fixtures. You can use different hook functions within that group of tests to modify the functionality. So in this case, you've got a test folder called foo with a test in it that tests something, and then also in your foo folder, you've got a conftest file that defines the Pytest run test setup hook function, and when the execution gets to that step, it's going to print out the item. And then you also have another group of tests in a folder called bar that does not have a conftest file, and as you can imagine, the output shows that when your test bar tests ran, it did not print out the line that was defined in the conftest, but when test foo ran, it did. Okay, so then the other type of plugins are third-party ones, things that you would install via pip. And you can get a full list of what's available at that URL. This is the sort of simplest one I could come up with as an example. Say you wanted to make all your tests always pass. So you could override the Pytest run test make report hook function and simply change the outcome of your test to passed. Let's see. this, I'll also say this demonstrates one of the ways that you can define these hook functions. You don't need it, they don't need to be decorated with anything, but if you do decorate it with this hook impl decorator, you can specify, for instance, that you want this hook function to run first before any other plugins, potentially, or last. Or if you define it, if you say it's a hook wrapper, that means it's actually going to wrap the execution of all the other hook functions that might also be in this phase of execution. And the way it does that is by returning a generator. So in that case, your function has to yield to receive the outcome of all the other plugins that run, or hook functions that run. Then you get that outcome and change your test results to passed. And then at the bottom here, you see how like a third-party plugin simply registers itself using setup tools. You define in your setup configuration, you specify an entry point, and the Pytest software looks for this Pytest 1.1. Not sure what the meaning of that is exactly, but so we're telling it that to register ourselves as the VW plugin, and give it that designation. So, all right, now I'm going to go through the different phases and show you some examples of some of the kinds of things that you can do. So in the initialization phase, for instance, and I should say, some of these examples, actually a lot of these examples, I found just by browsing through GitHub repositories of other Python plugins. If you're curious about the source of any of these, you can, the title here is a link to the code, although I'm realizing I'm not sure how you're going to get that link. But anyway, we'll figure that out if you need to. So in this first example, we're overriding the Pytest command line preparse. We're looking to see if the, yeah, I know. Yep, testing. Try that, okay. We're looking to see if the xdist plugin is also installed. Xdist is a Pytest plugin that lets you parallelize your tests, run them on multiple machines, or multiple CPUs, sorry. And if it finds it, it automatically adds to your command line arguments to Pytest to run in number of threads. The second example here is if you want to add command line arguments to the Pytest program itself. So let's see. So say you wanted to execute all of your tests in lexical order, or reverse lexical order. I don't know why you would want to do that, but someone did. And this is the code that they wrote to do that. Let's see, the second example here is where it's actually generating the test item, or the test function item. It's looking to see if the function that's under test is a coroutine. And if it is, it runs it in a special way. This is from the actual Pytest code. This is the Pytest runner.py. This is what happens in the Pytest run test call core function. But you could override that and do something else if you wanted to. It calls run test on the item and then collects any exceptions, and it does some, I've truncated here to save some space. And then here's an example of a plugin that's capturing output. So it uses the hook wrapper function, so that it turns on capturing and then yields so that other hook functions can do their stuff. And then when it comes back, it turns capture off again. So then the reporting phase, you can generate, you can specify different characters or different output for the report. And this is an example of a plugin called Pytest Sugar. It gives you very pretty test output. That's the kind of stuff you can do. right, so that's enough about plugins, hopefully. We talked about Ghost Inspector. It is what I think is like a pretty cool website testing service in the cloud. You create an account, you set up some tests. You can run those tests through their web UI, you can run them through their API. It has a Chrome extension that lets you record those. You can actually record tests in your browser, which I'll show you in a second. And once you've recorded or created tests, you can then go into their UI, edit the steps in those tests, tweak them. If you want more than 100 tests a month, which is not really that much, you can also, it's like the parent company is called RunScope. And I found out after asking for an increase in my trial, they said just go sign up for a RunScope account, and we'll bump up your limit. All right, so here's where I poke the bear and try a live demo. So here's the Ghost Inspector website. Let me font up a little. Let's get a little bigger. And sign in. All right, I'm already signed in. Once you're signed in, there'll be a button here. You can install the Chrome Recorder extension. I have it already here somewhere. And I'm going to record a test by going to pytest.org. Up. Ghost Inspector. All right. So I've activated, I hit Ghost Inspector. I'm going to say start recording. Now it's recording what I'm doing. Go in here, parameterized keyword. I search for that. See it in my search results. Say, say for instance, I want my test to, just like checking to see that the search term gets the desired results. So now I'm going to go back to the Pytest extension. I'm going to say I want to make an assertion on this page. I get a selector. I go down here and I say I want parameterized to show up in one of my test results. Go back and I say I'm done. And I call my test Pytest search. And I save it. And then I can go to the Ghost Inspector site and watch. And then it's now running my test. Takes a few seconds usually. It's not the speediest service. I find it usually takes anywhere from 15 to 30 seconds for even a simple test. Unfortunately, it's one of the things that I think could be improved quite a bit. So our test executed, it passed. You can see we've got a green bar. The interface shows us the different steps that it took. So you can see it recorded that I clicked on the page. I clicked on an input named Q. I entered some text, and then this last part is the assertion. It sort of inspected and saw that I wanted the text parameterized to appear in this CSS selector. I can watch a video of the test actually executed. There it goes. Let's see. So I can do a lot of different things here, including edit the steps. So I can rename it. I can schedule it to run at a certain time or a certain schedule. I can change the URL that I start with. So if, for instance, you had different dev servers, you're firing up new EC2 instances, and you can always point it to the system that you want to test. I can change to Firefox or a different version of Phantom.js, different notification options. Let's cancel out of this. And I want to show the actual steps. So now I can actually go in here and edit these steps if I want to. I'm not going to do that yet. What I'm going to do actually is I'm going to make a copy of this test, duplicate this. So now I got two tests. I have a suite called New Suite, and I have two tests, Pytest Search, Pytest Copy. I'm going to Pytest Copy. I'm going to make one change, so I can show you something else. I'm going to change this to a variable. I'm saying when I execute this test, I'm going to provide a parameter called search term, and I'm going to search for that term, and then I'm going to expect it in the results. So let's see. Now, let's go back to our presentation. So far, so good. So a little bit about the API. There's a few more API endpoints than this, but these are the most important ones. You can do things to tests, and you can do things to suites. So you can list the tests in a suite, you can execute a whole suite, you can download it as exported Selenium, so forth. And then when you execute tests, you can send different parameters. Most important ones being the API key, that's your authentication token to the system. You can specify a different start URL for your test. You can tell it to send a success or failure to a different webhooks. And then this last one, var name, you could send to the test execution through the API arbitrary parameters. So if you remember, I changed that step to include a search term. That's how I'm going to tell it. That's how I'm going to provide that value. Okay, so now a little bit. Let's go and talk about Pytest Ghost Inspector. So this plugin basically wraps the execution of those those Ghost Inspector tests within Pytest, so that you get standard Pytest report output for them. Why would you want to do that? Well, I mean, if you've got a big directory full of unit tests, but your application also has website or UI tests that you want to run at the same time, you can run them all within Pytest and have the report sent to Jenkins or whatever continuous integration system you're using, HipChat, Slack, whatever. So Pytest Ghost Inspector, pip installable. You specify the tests, the Ghost Inspector tests that you want to execute by either writing a YAML file, a very simple YAML file. It has to be called gi_test_something.yaml. And in that file, you just put in either test IDs or suite IDs. You get that from the Ghost Inspector UI. You can also, more conveniently, I think, or better, you can specify your tests or the suites that you want to execute on the command line through some additional command line options that the Pytest Ghost Inspector plugin adds. So there's Ghost Inspector API key. You can specify a start URL. You can give it a suite to execute a test, and you can specify those arbitrary parameters. Here's an example. So here's my API key. I'm telling it this is the URL I want you to start with. Here's the suite I want you to execute, and then my parameters are username equals guest, password equals foobar. If you don't want to type that stuff out every time, you can also put it in the Pytest INI file with the add opts. It's just a standard Pytest INI convention. So the way that this works, when you execute Pytest with the Pytest Ghost Inspector plugin installed, it will look to see if you have given it a GI test or a GI suite in the command line arguments. If you do, it will actually create temporary YAML files that it can then later discover, and then adds those file paths to the end of the command line arguments. Then during the discovery part of the Pytest execution, it looks for those files. It queries the Ghost Inspector API to get the metadata for those tests, generates Pytest items, issues the API requests again to actually execute the tests, collects the status of the tests from the API, and gives you the results. I'll go into a little bit about the hook methods that I use to do this. First of all, simply just to add the additional command line arguments, you override or you implement the Pytest add option hook function. I've truncated a lot of these, but you can get the idea. You just, I think it uses opt parse or under the hood or arg parse. For the actual collection part, when Pytest is crawling through your directory structure looking for test files, each file that it finds gets passed to this Pytest collect file hook function, and this looks to see if it starts with GI test and ends with .yaml. And if it finds those, it checks to make sure you've got a GI key specified somewhere, or you've given it one, or the API key. And if you do, then it creates a collector object to get that YAML and generate the tests. So the collector object implements this collect function, or collect method, loads the YAML, generates test items, and see here where it's querying the API to get the configuration for the test. So it wants to get the name of the test, it wants to get the suite name, some other things, and then actually generates the test items here. So this is a I wanted to explain the generating of the temporary YAML files was an approach that I took that evolved out of how this was kind of developed. I originally wrote it so that you would just be able to write these YAML files that specified your test details. And then I realized it would be really nice to just do this with command line arguments too. And the easiest way to go forward with that was to just generate these temporary YAML files. So we override this Pytest collection hook function. We look to see if we've got GI suites or GI tests defined, or that we're going to execute some. And if we don't, we simply yield back to the process. If we do, then we make a tip directory, generate the temporary YAML files, add them to the command line arguments, and then yield back to the process. And then when we run the tests, we make a call to the Ghost Inspector API, get the results. If it's not a passing test, we raise an exception, and then we report the failure with the information that comes back from Ghost Inspector and the API response. That includes the name of the test, what failed, what step it failed on, what value it was expecting possibly. So let me go and demo that really quickly. Oh, I'm already over time. Great. Ned, is it okay if I keep going? You're not going to kick me off, right? Sure. Pip install Pytest. All right. So I'm in a virtual environment here, obviously, and I can say Pytest help. You can see I've got my Ghost Inspector parameters in there. We are going to say Pytest key equals, and I have to copy my key out of here. So if I look at this, oops. We're just going to show what would actually run. Oh, that's a test. Sorry. you can see it. I found 2 tests. I got my Pytest search, I got my Pytest copy. And we'll just run this test. Then I'll make a haste of it. And here's where I'm going to pass in that search term. So it's running, collected 1 item. Come back to that in a second. Yep, I do. So I'm going to skip talking about the tests, and I will say thank you to everybody who came tonight, especially Ned, who gave me some good feedback on the slide deck. Font up. Don't use black backgrounds. Wise Ned. Pytest contributors, great product. Some things I used to kind of develop this, and I think Ghost Inspector, just a pretty great product overall. So there you can see we passed our test. We can go back to, why don't we, you guys, if anybody has any questions, go ahead and fire away.
Questions? Someone else have a question? Yeah.
On Periscope, they're asking, can we get these slides?
Yeah, sure. How would be the best way to
Stephanie
do
is
that?
bravely battling tennis elbow,
So these
holding
part-
the entire presentation to record it.
So these slides live on slides.com. James Luger Pytest plugins. That's public URL. Anybody can view it, run it, copy it, fork it. Sorry?
Well, comment in the meetup is a really good way to do it.
That's what I'll do. I will do that. Yeah, I know I had to run through these faster than I wanted to for stuff where I was showing a lot of code, but let's go back to, you can see here the test steps that we executed. The copy of the test, there's the search term that I provided on the command line. And if I had time, I'd show you like what failures look like and everything, but I think that's good. Any other questions?
Other questions?
Yep.
When you were talking about plugins earlier,
Yeah.
there was a thing called Make Report.
Make report, yeah.
Why would anybody want everything to be passed?
Why would everybody, that was a joke.
Oh.
That was a joke. Well, if you're, so there really is a Pytest plugin. Somebody actually wrote this. I found this out after I made that example. I was like trying to see if that would actually do what I wanted it to do, and I found out somebody wrote Pytest VW. It looks to see if it is running in the context of a continuous integration service like Circle CI or something. And if it is, all your tests will pass automatically.
It was for JavaScript, I guess. The first version was for JavaScript.
Yeah, I think every language has the joke has legs, as they say. Yep. Yes.
How does Ghost Inspector handle like long-running tests? So, say you have UI that kicks off the job, which process.
Yeah. So there's a lot of things that you can do in these steps. If you work with Selenium, you'll recognize a lot of the options you have. So any of the steps that you have here. There's different functionality that you can do. So in this step, I'm assigning a variable to an input field, but I can also do things like execute some JavaScript or assert whether elements are present. One of the really cool things you can do is import steps from another test. So say that the site that is under test that you want to test has a login screen. It's the first thing you have to do. You write those steps in a separate Ghost Inspector test, like kind of a library function or something, and then you import them into other tests that you write. So in that way, you don't have to repeat yourself endlessly, just to log into the site before running your tests. I don't think I answered your question very well. Long-running stuff. So one of the things that I've had to test is a UI where you're uploading a video. It's like a 10 gigabyte video potentially. It chunks it. It has like a dialogue thing that pops up that cycles and has a spinner and stuff. And you can actually tell Ghost Inspector to wait until that dialogue element is no longer present.
How long is it going to take to run? Just out of curiosity.
Well, it takes as long as the actual
Yeah, no,
UI operation, obviously. But yeah, it doesn't seem to me like the complexity of the tests influences the length of time that Ghost Inspector takes to run them.
No, I meant literally how long. Like I understand it's the
Yeah.
length of time to upload, but how long did it take?
Oh, like a 10 megabyte file?
Yeah, because I want to know. I'm basically wondering, does the framework's perfectly happy to wait like an hour or 10
Oh
minutes?
yeah. I think so. I think like there's timeouts for when it's looking for elements in the page. If you say click, input this value into field Q, if it can't find Q within 20 seconds, it gives up and fails. But the actual length of time of like your different steps, I don't know if it has a time.
We're going to get
It's
into
long.
timeouts in the next talk.
That's a good question. though. I don't really know.
Last
That's
question.
exactly.
Jenny.
What are your favorite features about Ghost Inspector that Selenium doesn't have?
So I'll tell you, the value for us at DCE, we have a staff of QA people who are not super technical. So asking them to write Selenium tests or even edit them was something we didn't want to have to do. We thought that this UI where gave them afforded them like more input into the test process, allowed them to actually go in and if they can record the tests using the Chrome extension, maybe with some help from us, edit the steps to make things work. We thought that was probably the best way forward. It has to do with like the technical level of the people that are using your tool and actually creating your tests.
Thank you.
Great. Okay.
10-minute break and then I'm starting sharply at 8 o'clock.
What? I'm sorry. Or do you want to come up here and say that?
10-minute break and then I'm starting my talk sharply at 8 o'clock. So if
Yeah,
you
good.
need a slice of pizza.
Luckily,
or,
Michael's plan coincides precisely with mine. So we're going to be working